Okay, this is a video on lesson 1.5, angle relationships. Again, at any time you can pause this video and take notes. You can copy down the pictures as we're doing them. It's very important that you copy down the definitions as I write them, and then we'll do some problems real quick, and then I'll assign your homework tomorrow in class. Adjacent angles. Adjacent, if you've ever heard of that word before, adjacent really means next to. If you have like two homes that are adjacent, they're next to each other. So adjacent angles, similar concept. They would be two angles that lie in the same plane and have a common vertex. And a common side. But no common interior points. So, adjacent angles, like I've given you right here, changed from black marker to red, would be angle CAT. Angle CAT would be adjacent to angle TAP. They both share a common vertex. They both have a common side, meaning again, a ray, but they don't have common interior points, which I'll give you an example of in a minute. These two are adjacent. And then angle 1 and angle 2, those two are adjacent. They're next to each other. They share a common side and a common vertex. Here's an example if I said AOC, this one right here, and then I said BOD. Notice they're sharing a vertex. They're not really sharing a common side at all, and there's points that are on the interior that they don't have in common. So those two are not adjacent. They have to be sharing something. Like this was sharing that ray, this was sharing that ray. All right, vertical angles are two non-adjacent. Oh, now they're not next to each other. Non-adjacent angles formed by two intersecting lines. So here, I love vertical angles. Vertical angles are so cool. So like, here's an example. You just like make a cross or a plus sign, and the ones that they're pretty much opposite. So here's a vertical angle, here's a vertical angle. Even these two right here, these are both vertical angles. Something really cool, a known fact about them is, write this down, that vertical angles are congruent. They are equal. That is going to become huge, huge, huge. All right, now let's practice that. Let's find x and the measure of angle God. Whether you think it's God or you think it's dog, it's still the same angle. But if we look at this picture right here, and again, draw this picture, you need to draw these pictures, okay? Are these two vertical? Are they directly opposite each other? They are. So you can just set them equal. 5x equals x plus 16. Solve for x. X equals 4. So you found x, but you always want to go back and find the measure of the angle. So plug 4 in, you would get 20 degrees, 20 degrees. So that is x and the measure of angle God. Now, a linear pair. So linear pair, look at the word that it has in it. Linear, line. They need to form a line, don't you think? So a linear pair would be a pair of adjacent angles whose non-common sides are opposite rays. And if you remember from the last lesson what opposite rays look like, those are straight opposite each other. So if you're kind of looking at this picture right now, could you give me two angles that seem to form a line? Like you wouldn't say 1 and 4. They're forming an angle, but not a line. But if you look right here at 1 and angle 2, together they look like they're forming a line. Look right there. That's a line. So angle 1 and angle 2 are linear pairs. Angle 1 and angle 2 are linear pairs. Now, another little known fact. Put a little star. Angles in a linear pair are supplementary. Angles that form a linear pair obviously are going to be supplementary. Now, if you don't know what supplementary is, you should remember what that is. That means they make two angles whose measures add to 180. You should know that one. All right, let's do an example of that. Find x and the measure of angle POG. Find x and the measure of angle POG. Okay, so if I'm looking at my picture again, I see this is 9x minus 4, this is 4x minus 11. Are they vertical? Are they opposite? Nope. Are they forming a linear pair? Yeah, they look. They're making a line. This guy and this guy. So you're not going to put them equal to each other. You're going to make them add to be 180 because two linear pairs make 180. And do just a very simple algebra. 13x minus 15 equals 180. 13x equals 195. X is 15. So we found x. Plug it back in. If I plug it into this one, 9 times 15 minus 4 would be 131 degrees. Plug 15 into this one. 4 times 15 minus 11 makes 49 degrees. And hey, those two together make 180. Now remember, always go back and answer the question. The question didn't ask you to find angle DOT. It didn't ask you to find angle DOG. It asked you to find POG. P-O-G. That guy. Well, what's that vertical to? It's vertical to the 131. So POG is 131 degrees. Make sure you draw that and have that down. If you don't, pause the video. Another definition. Complementary angles. Two angles with measures that have a sum of 90 degrees. So looking at this picture right here, two angles that have a sum of 90 degrees. By the way, they don't necessarily have to be adjacent. In this picture, they are adjacent, but they're not always going to be adjacent. But angle TOY, toy, and angle U are complementary. Let's do an example of that. Find x and the measure of both angles. So again, draw this picture out. These two angles are complementary. They're 90 degrees. To show that they're 90 degrees, we usually put a box, by the way, a little corner. And I should have drawn that in this picture. So I'm just letting you know the box is there. So we would say 4x minus 3 plus x plus 8 equals 90. And then again, do your simple math, combine your like terms. 5x equals 85, x must be 17. So if x is 17, plug that back in here. 4 times 17 minus 3 is 65 degrees. And then 17 plus 8 is 25 degrees. And yes, both of those add up to 90 degrees. All right, supplementary angles. We just talked about that. Two angles with measures that have a sum of 180 degrees. So when you see a picture like this, again, forming that line, we always look for that line. Those two angles that comprise that line must make 180. So 7x plus 10 plus the 3x must make 180. So 10x plus 10 equals 180. 10x equals 170. X is 17. That must be my favorite magic number lately. Plug it back in. 3 times 17 is 51. And then this would be 129. If you did it out. Easy. This is easy, fun, easy breezy stuff. All right. A few more things. Perpendicular lines. Perpendicular lines are line segments that form right angles. So if you see line segments and they're forming right angles like this, then you can say that these two lines are perpendicular. The symbol for perpendicular is an upside down T, and you call it line, remember, by a cursive lowercase l and a lowercase m, or you can name a line by 2 points. There's no points on here. But these two lines are perpendicular. Now, just a quick note, you don't have to write this down, but I do want you to know this, that lines may be perpendicular to planes. If a line is perpendicular to a plane, then that line must be perpendicular to every line that it intersects in that plane. So we can say that line AB is perpendicular to the plane E. Then line AB must be perpendicular to every one of these lines that it's intersecting, okay? And this was on page 48, if you want to refer to it. Don't have to write this down. Just know this in a plane. But something I would like you to kind of recall, this is on page 49. When you look at this figure, you have to, because we're about to get into the chapter that deals with what are called proofs, you have to be able to look at a figure and safely assume things and things that you cannot assume. So looking at this picture right now, you want to be like, oh, this looks like it's a right angle. Is it a right angle? Does it have a right angle box there? If it doesn't, you cannot assume that, okay? So you just can't say, oh, these two look like they're the same. They're equal to each other. You know, angle MPL is congruent to that. You cannot do that unless you see marks. Here's what you can assume. That the points are coplanar. That these 3 points are collinear. That the rays are forming an angle and intersect at point P, that P is between L and Q. Notice nothing about right angles or the measures of the angles. Now, I can safely assume that L, P, and Q are opposite rays, and that I can say that QPO and OPL form linear pairs, things like that. But I cannot just say, oh, I know what the measure of this is, okay? So when you look at a picture like this, Now I've given you some markings on here. I just want you to pause the video if you can, draw this out, and take a list of some things that you can assume from this picture right now. Here's what you can assume. These two congruent marks mean that you can say that PL is congruent to PQ. That is safe to assume. These two congruent marks mean that this angle, QPO, is also congruent to LPM. That you can, because they have congruent marks. You see that mark right there? Okay, that forms a right angle. So we can assume that MPN, angle MPN, is a right angle. Okay, we can also know that the measure of angle MPN is 90 degrees, because right angles make 90 degrees. So this is where you want to be very careful in geometry about things that look, oh, it looks like it's 90 degrees. It doesn't necessarily mean it is unless you see that box. Same thing about congruent measures. Okay, that's it.